Hi, welcome back. So we're in Chapter 3, Descriptive Analysis on the Central Tendency discussion. In this outline, we're going to discuss the first tool that we can use in order to calculate the mean. Let me take you to a visual presentation on that. Now, having a variable x, one of the most important characteristics in order to utilize the use of mean must have a value or the outcome, a form of continuous. Let me share with you a following example. Imagine if we would have a vector of s1 to n, for example. In order to calculate the mean, basically what you do, you take the summation of all those subjects from the first subject all the way to the last subject, divide the result of that by the total number of those subjects. Let me share with you a quick example. Now, according to the formula straightforward, the summation of all these values, and what you do next, you divide the 170 by 5 subjects, and that give you value of 34. Sample referred to the mean. If this number of subjects are my entire population, then we refer to the sample that represent the mean in the form of mu. If you are doing the calculation for a sample, these are as a sample, which most likely is going to happen, then we refer to the mean as x hat. So if this is a sample. One more important thing I wanted to share with you, any number we calculate on the entire population, we call it a parameter. Any number we calculate on a sample, we call it statistics. So in this case, if happened that my mean is drawn from a sample, it is a statistics mean. If it's drawn from the population, then there is a parameter. Next thing I wanted to share with you, what does this number tells you? That if a new subject happens to come to this list, the assumption of this value, it will be taken by the value of x bar. In other words, I expect its value to be 34. That's why, in other words, you can call it the mean or the expected value. Next thing I wanted to discuss with you is the following scenario. Assume you would have this list of values. Now, it's saying that my expected value or the mean happens to be 444, which is way far from reality. I expected the value, or it will be range in the form of 300 or so. But how comes 400? The reason I think quite obvious, because of the outlier 800 plus. So the calculation of the expected value, it's quite sensitive to outlier. This kind of mean, it's called an arithmetic mean. Now, the other type of mean that you might hear of is called the geometric mean, which is basically follow a different formula instead of this one. Basically, it take the total product, the dot product of all the values of the subject, and then it of the number of the subject. In other words, for example, if I would have to make the calculation for this, that means you just take the root of 5, since there are 5 subjects here, to that big number, and then you will get a value around 375 or so, which is way close to the reality of the actual values. But the only disadvantage I see from a computational power perspective is the use of multiplication instead of summation. But still, the use of geometric mean calculations are quite beneficial, especially in the financial domain. I hope the idea of expected value or the idea of the mean, either in the form of arithmetic or the form of geometric, is quite clear to you. We have accomplished that. We are ready to discuss the second, and that is the calculation of the median. I will see you then.